Dear friends, welcome to this video on difference equations. So in this topic, now first we will see the definition of this difference equation. So definition of this difference equation. So what does it says? And difference equation is an equation which contains an independent variable, a dependent variable, and one or more differences of a dependent variable, then that equation is called as a difference equation. That is, I can say here it contains of an equation contains independent variable, x, and a dependent variable y, and one or more dependent variable difference, one or more dependent variable differences. That is, I can say delta of y, delta square of y, dot dot dot, delta to the power of n of y is called difference equation. So here we can see it here, an equation which contains an independent variable, and dependent variable, and the differences, one or more dependent variable differences, that is this one, then that equation is called as a difference equation. So we can write an example here. So how it will be? So I can say f of x comma y comma delta of y comma delta square of y comma, so dot 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 up to delta power n of y. I will say this as a equation number 1. So we can see in this function here, in this function we can see here there is a independent variable x and dependent variable y, one or more differences, that is delta of y, delta square of y up to delta power of n. So this equation is known as a difference equation. So this is the definition of the difference equation. So now we will denote some way how to write some of the ways where we can write a difference equation. So this is the one of the way to write a difference equation. So if delta of y is equals to y of x plus 1 minus y of x. So this is the difference, delta forward difference of f of x is equals to f of x plus h minus f of x. So this is there. So after simplifying this one, equation 1 can be rewritten as f of x comma f y of x comma y of x plus 1 comma y of x plus 2 comma dot 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 dot, and up to y of x plus n. If delta of y is equals to y of x plus 1 minus yx, then I can write this first equation as like this, f of this one. This indicates the difference, x plus 2, x plus x, y of x plus 1, y of x plus 2, and so on. So now we have seen the definition of the difference equation. In general, we have the equation f of x comma y comma delta of y delta square of y so on dot dot delta to the power of n of y is equals to 0. If delta of y is equals to y of x plus 1 minus y of x, and we simplify, then we can write this equation 1 can be written as f of x comma y of x comma y of x plus 1 comma y of x plus 2 comma dot 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 up to y of x plus n. This also can be written in the form of f of x comma y of x comma y of x plus h comma y of x plus 2h comma dot 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 y of x plus 2n is equals to 0. Sorry, this is n h. And another way of writing this one is g of k comma y of k plus 1 comma y of k comma y of k plus 1 y of k plus 2 dot 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 y of k plus n is equals to 0. And this can be written in the form of k comma y of k comma y of e times of y of k comma e square of y of k comma dot 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 e power n times of y of k is equals to 0. Fifth one, that is shift operator E. So here this 5 are the general forms in which we can write the difference equations. These are the 5 forms where we can write. So many forms are there, but in this we are going to use, these are the notations of the difference equations. In the shift operator, here E is a shift operator. In general, from 1 to 5, from equation number 1 to 5, these equations are called as a difference equations. There are different ways to note it. Now we will see what is the order of the difference equation. We will define the order of the difference equation first. Now we see order of a difference equations. So what do you mean by order of a difference equation? It is the difference of largest and smallest arguments of k in the difference equation. That is, it is the differences of largest and smallest arguments of k in the difference equation. So the difference equation is a differences of largest and smallest argument of k in the difference equation. I'll show you by taking an example. Let us take an example. So the equation, the difference equation is like this. That is y of k plus 3 plus 3 times of y of k plus 2 plus 2 times of y of k is equals to 0. This is an difference equation, right? So now here I will find the, in this equation I will find the, what is the order of this equation. So I will define here what do you mean by order of a difference equation. That is, here the argument, what are that? This one, big one. That is the arguments of k. So here k plus 3 is there, k plus 2 is there, and k is there. We have to take largest and smallest arguments, and we have to make the differences of it. That is, I have to make like this. The largest argument is k plus 3 here, and smallest argument is k. If you make the differences of it, so its differences will be 3. So order of this equation, order of this difference equation is 3. That is, we have to take the, that is, we can say indirectly, we can say that the difference between the largest and smallest arguments of a k. I will take another example so that we can understand in a better way. So let us consider another example. Let the given difference equation be 2 times of y of k plus 1 is equals to 8 times of y of k plus 6. Now, what is the order of this equation? Now, here the largest argument, what is the largest argument in this equation? The largest argument in this equation is k plus 1. And what is the lowest, smallest? That is k. If you make the differences of it, then what will be our answer? Our answer is 1. So this 1 is called the order of the difference equation. So in this way we can define and we can find the order of the difference. We have seen the order of a difference equation. Now we see linear difference equation of order 2. Now write an equation. A naught of k y of k plus 2 plus a1 of k y of k plus 1 plus a2 of k y of k is equals to b of k, where a naught of k is not equal to 0. You will say this is a equation number 1. Now, here if we find this order of this equation, its order will be 2. K plus 2 minus k, k get cancels and it will be 2. Therefore, it is a linear, therefore it is called as a linear difference equation of order 2. Now, in this equation, if a naught of k, a1 of k and a2 of k are all constants, then equation 1 is known as, linear difference equation of order 2 with constant coefficient. That is a naught of k, a1 of k and a2 of k. They are all will become a constant values. They are not functions of k. Then the equation is known as a linear difference equation of order 2 with constant coefficient. Now, with this, that is a naught of k, a1 of k, a2 of k. They are all are constant and b of k is equals to 0. That is a naught of k, a1 of k, a2 of k. they are all are constants, they are all are some numbers, and b of k is equals to 0, then equation 1 is known as homogeneous linear difference equation of order 2 with constant coefficient. That is a naught of k, a1 of k, a2 of k, they are all are constant, and b of k is equals to 0, then it is called as a homogeneous linear difference equation of order 2 with constant coefficient. Now, second, if a naught of k, a1 of k, a2 of k are all functions of k, are the functions of k, they are the functions of k, then equation 1 is known as linear difference equation of order 2 with variable coefficient. With variable coefficient, that is here a naught of k, a1 of k and a2 of k, they are all are the functions of k, then that equation is known as a linear difference equation of order 2 with variable coefficient. Now in this equation, that is if a naught of k, a1 of k and a2 k are all are the functions of k, and with that b of k is not equal to 0. If they are not equal to, b of k is not equals to 0, then equation 1 is known as non-homogeneous linear difference equation of order 2 with variable coefficient. So we have seen here 4 type of equations. I am repeating here. If a naught of k, a1 of k, a2 of k, they are all are the constants, then that type of equation is known as a linear difference equation of order 2 with constant coefficient. And at the same time, if this a1, a2, a3, they are all are constant and b of k is equals to 0, then the equation is known as a homogeneous linear difference equation of order 2 with constant coefficient. If a naught of k, a1 of k and a2 of k, they are all are the functions of k, then that equation is known as a linear difference equation of order 2 with variable coefficient. And with this, if b of k is equals to 0, then it is a non-homogeneous linear difference equation of order 2 with variable coefficient. That is, b of k should not be equal to 0.